Hey everybody, welcome back. This is Graduate Statistics Week 13, University of Cincinnati. Let's continue on. We're trying to figure out some prediction equations for current milk production based on previous milk production and some information about the number of days passed since present lactation of cows. So let's write out the equation. If I'm going to predict the current milk production, I'll have the intercept 26.30. Where did I take that from? 26.30 plus 0.8 times previous. Where did I get the 0.8? Right here. And where did I get, and minus 13.58 times I-79. Where did I get that? I got it here. All right, so because this is categorical, we can actually write the equation of a line for each one of the levels of I-79, just like we did for the book example in class. So if you didn't watch the lecture video, go back there. It's important to watch that first before coming to the lab. All right, so let's do that for each level of I-79. When I-79 is equal to 0, we're talking about cows with less than 79 days since lactation. So let's predict current milk production for cows that have less than 79 days of lactation. So the intercept is the same, so we're writing out this equation, okay? So it's 26.30 plus 0.80 times previous minus 13.58 times 0, because we want the line for cows that have this equal 0. So because this product here will be 0, because anything times 0 is 0. So we have 26.30 plus 0.80 times previous, whatever previous production was. We multiply by that, sum this, and then we get the current production minus 0. So this term kind of drops out of the equation. And to predict the current milk production, if I have cows that have less than 79 days of lactation, this is the equation I want. And I'll be 62% certain of what I am saying, right? There's going to be some potential error in my prediction, but, the model is explaining 60% of the variance, 62% of the variance. That's not too bad. All right. If I want to predict for cows with more than 70 days lactation, then I need to plug 1 here for this, for the value of I-79. So this term doesn't go away, right? 13.58 times 1 is just 13.58, because this is just a number, just like this one. So let's subtract this from this. And we have the equation of the line to predict current milk production for cows with more than 79 days since present lactation. So you can see how the equation has the same slope for the line, but different intercepts. So let's do the overall interpretation of this first model in the context of data. What this model is telling us is that current milk production is directly proportional to previous milk production, such that each unit increase in previous milk production is related to 0.80 increase in current production. Cows with more than 79 days since lactation can be expected to produce 13.5 grams less milk than cows with less than 79 days since lactation, regardless of previous month production, right? We have no interaction effect there. The current model thus estimates the relationship between previous milk production and current milk production to be the same for cows with more and less days since lactation, right? So see, the slope is the same. So we expect that, let's say, if in month 1, I have a production of 3 pounds of milk, and in month 2, I have a production of 4 pounds of milk, I had a 1 unit change in current milk production, I would expect a 0.8 increase in current milk production, regardless of whether my cows are early lactators or late lactators, right? The scatter plot that we produced above, though, this one, suggests that this relationship might not be fixed, right? That the slopes might be a little different because we seem to just see the effect of this variable when production the previous month was kind of low. We don't see that effect as strong when for previous months with higher milk production, right? We see them more kind of mixed together. So we would expect sort of a flatter slope for cows that are early lactators and a more steep relationship for cows that are late lactators, right? What they did before is more important to what they will do this time around if they're late lactators and if they're new lactators, right? If they're new, what they did before might not quite match what they do now. So because of that, it's practically this suggests that the model will explain current milk production better if we introduce two slopes instead of just one. So in practice, this means adding an interaction between the variable previous and the variable I79. And I will work through this example carefully with you so you can see how that's the case. So the interaction term in the model is what allows slopes to vary. So we'll include the effect of previous, the effect of I79, and a multiplication between the two, an interaction between the two. So same thing for overall model. All coefficients in the model equals to 0. All of the effects, the main effects and the interaction, all 0. Alternative hypothesis, the model will be significant, statistically significant, if at least one of the model coefficients is significant. That is, if at least one of the terms in the model is helping us predict current milk production. For each coefficient, these two hypotheses you've seen before, I'm adding a hypothesis for the interaction. The null is that the coefficient for that will be 0, not reliable, and the alternative is that it will be different from 0. So here we have the same exact syntax, we're just adding an interaction term, which is kind of a product between the variable previous and the variable I79. That's how it shows up in the model. And I'll help you see how this shows up as a multiplication also in the equation. All right, so here is our model. So note that these two continue to be significant. When we fix the slope, there is still a contribution of this. There's still a contribution of this. But slope, even after we fix the effect of previous, the effect of I71, as the main effects of previous and I79, you still have an effect for the interaction. All right, that's reliable. The model is also reliable, but now instead of explaining just 62% of the variance, it's explaining a little bit more, 65%. And again, we're not penalized much for introducing one additional predictor because it's helpful, right? Because it's statistically reliable. So let's interpret the overall model first. At least one of the predictor variables is related to the response variable. We're seeing this P being statistically reliable when the other variables in the model are held constant, right? The F, we have now 3 degrees of freedom. We have 3 predictors now, and 122.9 error degrees of freedom. No, 195, sorry, error degrees of freedom, and the F value, I forgot to change these, is 122.9, and p-value less than 0.001. I'm rejecting the null hypothesis that all of the coefficients in the model are 0. That these 3 are 0. It's not likely to see those sizes of coefficients. At least one of them is unlikely to be observed under the null hypothesis that it is 0. Model explains 65% of the variance in current milk production, 3% more than the previous model without interaction. Not a crazy increase, but an increase nonetheless. Given that we know that a lot of the variance is being captured by previous milk production, we're just trying to ramp it up a little bit more with other variables. Let's interpret the findings with respect to specific predictors in terms of a hypothesis test. All terms in the model uniquely contribute to predict current milk production. So we'll reject null hypothesis 1, 2, and 3. Those three here. 1, 2, and 3 null hypothesis rejected. We keep the alternative hypothesis that those predictors are helpful. You've seen me interpret the intercept before. It continues to be the estimated value of current milk production when previous milk production was 0 and I-79 was 0. You saw me interpret coefficient for previous, same interpretation. It's just that it changes in value a little bit. Before it was 0.8 and now it's actually 0.46. So we need to change that. The coefficient for I-79-1 is the same, so we have just a different subtraction, right? So compared, again, our reference level is 0 because R is pointing out that we have the number 1 there. That you have to subtract 40 pounds for each unit. Well, 40 pounds for cows that have more, 40 pounds of current milk production, less for cows that have more lactation time than less lactation time. So that's this one, but it's not 13 pounds less, it's 40 pounds less of milk. But that's also not a general effect because the interaction effect is significant, so all else being equal in the model, an additional 0.43 pound increase in current milk production for each unit increase in previous milk production should be expected when I-79 equals to 1, right? So it's like if cows have more than 79 days of milk production, of lactation, then for each unit increase in the previous production, you have 0.46 plus 0.43. Sorry. So here is what we're saying in practice, that when previous milk production changes by 1 unit and I-79 is 1, current milk production will change by 0.46 plus 0.43. So you will change twice as much if I-79 equals to 1. It will change twice as much if we're looking at cows with more than 79 days of lactation, right? So we'll see how this plays out in the equations. I think it will make it clear for you. So let's look at the general equation here. We have here, we're predicting current milk production. This is the intercept of the model. I got it from here. This is the coefficient for previous. I got it from here. This is the coefficient for I-79. I got it from here. And this is the coefficient for the interaction term. I got it from here. Now we'll do the same exercise that we've done before. We'll create an equation for each level of I-79. When I-79 equals to 0, those are referring to cows with less than 79 days since lactation. Let's just look at the influence of previous milk production on current milk production for those cows. So for that, I'll have to set this one to 0. Here it is. And I'll have to set this guy here to 0. Now, 40.83 times 0 is 0, so this term disappears. The term inside parentheses here will be 0 because anything, whatever previous is, if I multiply by 0, it's 0. And then if I multiply by this coefficient, it will be 0. So these terms disappear. So here is our regression equation to predict current milk production from previous milk production for cows with less than 79 days since present lactation. If previous milk production increases by 1 unit, current milk production will increase by 0.46. And that's the intercept of the model, okay? That's where the line, where the expected production when previous milk production was 0. So that's a constant. You always add that to this product here. Okay, so you start out at 47.64 and you add 0.46 for each unit increase in previous milk production. Now for I-79 equals 9. Now we're talking about cows that have been lactating for longer. Here is, so I'm using the same equation, okay? But now I'm plugging in one here and here. Now, 40.83 times 1 is 40.83. 0.43 times previous times 1, whatever previous production is, will be here. So here is what we have. Now let's simplify that. We'll subtract this number here from this number here, and that's the intercept. So you expect to start lower. If you have 0 milk production in the previous month, this is if you have 0 milk production, this will be what you expect currently if your cows have more than 79 days lactation, so less than that. So the line starts lower, but it increases quicker with increases in previous milk production because I'm summing this 0.46 times previous with this term here, 0.43 times previous. I'm summing this and this. So for cows with more than 79 days of lactation, increases in previous milk production will have a greater impact on current milk production, right? It will increase 1.23 the current milk production. All right? So we're saying that what you can expect in terms of current milk production based on previous milk production depends on whether you have young cows or if you have not young cows, cows that have been that began lactating recently, or if you have cows that have been lactating for a while. So we'll come back to look at plots and play around with making some predictions. I'll see you then.